So we talked about schematic a little bit.
So we were busy.
Yeah.
15 minutes. I'll give you half an hour. Schematics. We talked about 3 types of schematics. What are they? Pictorial, factual, and installation. Some of them are easier than others to read, and some of them have more information than others. So, we'll talk about how to read and interpret electrical schematics. Be familiar with the electrical symbols. And again, we said symbols usually changes from one industry to another. They're not always the same. But we know what is the general schematic and symbol for some components. Be able to draw simple schematics. One of the labs will have you draw simple schematics, basically connecting all the components to each other from the source to the load. What are the components of a electrical circuit? Power load, power source, wires. So you need a complete circuit, you need load, and you need source. So, what you got the late. Trace electrical circuit. What do you mean by tracing?
Like power flow?
Yeah. So we do the power flow from the source, till the load, and back either to the ground or to the neutral. If you do DC current, usually there is no return line, there's no neutral. What do? Ground. So that's why in the car, you can see you can put it only to one output and to use the car body as a ground, and you have enough flow. And it's not that much amperage sometimes for the components, but you see the mechanic or the car electrician will plug in one thing and just touch the car body and that'll be your ground, because it's direct circuit. For AC, which is the house, you need neutral. You need path back. If you don't have neutral, probably things they're not going to work. And especially with the AC over, you can measure the amount of AC by touching the ground. So there are many types used in the industry. They're not all the same. They do not come from the same print. They have, some of them have colors, some of them are black and white. Again, the symbols do change from one industry to another. Used for multiple purpose. Some of them for installation. So they will tell you what terminals goes into each wire, and they can get a little bit involved. But I'll show you a few boards here that you will have to connect. So this is switching board. And you can also have a zone valve switching boards. If you have a house that has 3 zones, the first floor, second floor, garage, you need something to determine which one receives heat or not. So you're gonna have some kind of a switching board. And it's your job to wire that switching boards. And to do so, you have to follow the right instruction. And most control equipment are how many volts? Control. 24. And equipment are 110. What happens if you connect the wrong thing into this terminal? If it's supposed to work on 24 and put 110, you fry the board. And it happens a lot, more than you think. If this terminal, for example, is designed to run in 24 and you put 120 here, the board will be fried. And these boards are not fixable. See, it's all printed in. So you're probably gonna fry the board, you have to change the entire board. These boards range from like $200 to $500.
What is that exactly for?
This is switching relay for like different zones, multi-zones. These are the relays, actual relays, switches. So we need to know the installation diagram and make sure the wires, what kind of wire goes where. Usually they are numbered and sometimes they are colored. Where are the electric components in the control panel? What power source going in which terminal, and how to troubleshoot. So, troubleshooting is very important, especially if something goes wrong with the equipment. For example, if we look at a primary control, that's something you will have to wire. Probably this semester at the end, if you cover everything, or next semester. If you look at the back, it has labels for everything. Should I put it in the projector? I'll pass it around. If you look here, these things are labeled, and each one of this goes to certain equipment. If you mix them up, probably you mixed up the sequence of operation, and probably it's not going to work as well. So here it says ignition. This one goes to the burner motor. This one is L1 coming in, and these are all neutral. We have something that goes to limit and valve. Don't be overwhelmed now because we will study these very well. And if you look in the top, you will see the small little diagram. If you look at it long enough, probably you understand it's not that bad. It shows the lines and where everything goes and how to come back. So my purpose here for this week and next week and the following 2 weeks is to get you familiar with what those symbols mean. So when you look at it, you can translate that into something you will do. What does the line mean? What does two lines intersecting mean? So we'll look at some schematics and we comment on. So limitations, most of the industries emphasize the part of the industry for which they are used. So mostly they will label things and call them based on their equipment. So the colors usually in oil and gas are similar. For us, usually the black is the line voltage coming into the equipment. White is what? Neutral. Blue for oil and gas and heat usually is ignition. Orange, it's well known to be the motor line, orange. The pink one is the valve for gas. If it's purple, it is for the oil valve for oil. You'll remember these after you use them a few times.
I was reading something last night where the green wire was the
Yeah, either green or bare.
Okay.
Yeah, we don't see any green wire here. Limit. What do you think limit is?
current.
Shouldn't it shut down after a certain limit?
Yeah, so limit usually is whether it's a thermostat, high pressure switch, or low pressure switch that will shut off the entire thing. So the whole thing is wired. If this wire is activated, then the whole equipment will shut down. So that's the limit. Remember that. For these two primary controls, the limit is supposed to be energized. If it gives power, then because the relay here is normally open, so you have to make it normally closed. So you have to energize the limit. So the limit by default is normally closed. I have to energize the limit. So I will supply power to the outline and also to the limit. You don't have to remember this for now. We'll go over it again a lot. So there is something called the ladder diagram. We saw that last class where we go from the line voltage and step down to every piece of equipment. A point 2 for installing and troubleshooting provides information regarding equipment operation. Modes based on the switches, installation connections, how our things are connected, whether they are in parallel or they are in series. Troubleshooting and repair. If something goes wrong, probably there's some indication light, or it will show you what might have been wrong. Components, how do they work? Okay, let's look at one of the schematics. We looked at something similar last time, and this, from the looks of it, it's an AC, a simple window AC. I should look at the exact things last class. I would say this between those two lines is the line voltage. Line 1 is hot, line 2 neutral. What is this, Felipe? Yeah, and this is the control board, right? And this controls 24 volts and provides signals to close the contact here. And this relay will turn on the fan motor. And what is this box here? Thermostat. It's my thermostat. So as soon as we identify each one of those components, things will make more sense. And this is very simple schematic for a window AC flushing.
So that would be on the guide, right?
Yeah.
Let's say if you was in the
Yeah,
actual field, that
should
would
be.
be on the guide.
And sometimes it's, there is a sticker on the outside of the AC. If you handle a small air conditioner, there will be a sticker on it, tell you what are the components. It should be there, yeah.
What's the two lines between the two?
Just symbolic. The whole thing is that this symbolizes a transformer. Sometimes there's no two lines. They get a little bit confusing. What is that? What does it do different? Just don't fixate on that. Only symbol means that. And go and look it up. This I will assume it's a transformer. And what do you do if there's no schematics? Yes. Thank God that there's a lot of schematics everywhere.
Do it by your head.
Huh? There's schematics everywhere now. Well, you just print it out, you call the company and they'll send you a print, but that's really annoying. It takes time, and now you just Google, for example, get the model number, Honeywell, primary control. I'll Google this thing, for example. Honeywell control, and it's R7184. I'll get the entire manual on PDF. And it's good to have them printed out ready for you. Most of the equipment you work with will be very repetitive, so they'll be the same, and you can have these with you. After you read them a few times, probably you don't need them anymore. You know it by heart, unless you go across a new control, some different company like Riello or what is the other one, week7. The idea is the same. Like you work with cars are the same. The components are the same, so a little different strategies of putting the equipment. Like you work in a Mercedes, it's gonna have the same components as the camera. Just different strategies, different tools, different layout. Yeah, of course. Different reliability too. Schematic diagrams present bilateral, two vertical lines represent the incoming electrical sources. This is the energy supplied. So if we look here again, usually in some schematic they put a number here. 110 or 240, that's your line voltage. And you see L1 and L2, it says either 110 or 220. Components made up of series and parallel circuits, circuit by circuit arrangement, focus on the one part of the system. So I will show you some overwhelming schematics where you have some big schematics and they just put every component spread out by itself. So focus on your circuit, try to trace it out. And again, the first thing you do when you look at schematic is what? Yes? Yes. What is the first thing you do when you look at schematic? Do not panic. Do not panic. Do not panic. Just look at it piece by piece and it should make sense. And now you're getting exposed to a lot of components. You have the book with you. You can be more familiar with it. What about this one here? Very easy. Compressor, blower motor, contactors, blower relay. What is the line voltage here? 240. What is one stands for?
What?
We didn't cover that yet. The number one here. That's phase.
One circuit?
No, it's phase. We did not cover that yet. We'll cover it. 60. What would you assume 60 is? Huh? No. Hertz. Frequency. So usually if they give you 240 or something higher, they should give you the details of what voltage is required. 240 volts, one phase, 60 hertz. Compressor needs some contacts. These are the contacts, and this is the control for the contact. And blower motor, that's again simple AC with no thermostat. On and off, to turn it on, you turn on your compressor relay, the blower motor relay, and the thing turns on. This is very, very, very simple. No board, no thermostat, nothing. On or off. That looks very simple and easy to read. So we have, there are some basic schematics in the book, which are very useful. I'm not going to go over all of them. We'll address some of the most important ones that we should cover. The humidifier will look a lot like an AC, window air conditioner. walk-in cooler, probably cover these in details in Bill's class. I'm gonna focus on gas furnace and oil burners. And once you understand the main concept, the main components, it's not going to be that difficult. It takes practice. I think it takes you a while to be familiar with it. This is the first time you drive in a car, right? You have to go be familiar with all the knobs, all the switches, the paddles, where they go. So it's same thing. The first few weeks going to be a little bit difficult. But now, do you even think when you drive? No, you don't just think. You just get into a car and it becomes second nature. So we'll cover a few diagrams and we'll have you work on them. And again, I don't expect you to remember everything like 100%, but whatever you remember when there's 20%, see what is familiar. I'm sure if you look at the diagram, at least you know 20% of it. So we'll see what's familiar and we'll fill in the gaps. This is another AC, wind air conditioner. So look at the switch. First, the voltage between the line 1 and line 2 is 240. Fan motor and compressor, thermostat, and we have 2 modes. So if we connect 1 to 2, what do we get?
The fan motor.
Fan only by itself. And you see that option, fan only. This one, if you connect both,
You get everything on faster.
you get the compressor and the fan motor. Can you turn the compressor by itself? No.
No.
That will be not productive. So either fan motor or compressor and fan together. That's a very simple switch. And a thermostat will engage or disengage the AC. So based on that, probably you can make your own AC. This is a schematic of an AC in the back. Actually, that's an AC being laid out with all the components. This is the compressor, condenser, collection. This is the condenser, this is the evaporator, and all the lines in it. So that's an AC. I can turn on to start cooling the heat. Simple components and simple wiring. Okay, I'll stop here. I'll finish on Monday, and we'll do the quiz.